everybody. And this is us. If you want to keep the conversation going, that's us on Twitter. Slide credit has to go to my other partner in crime, John Starmer. John also runs the user group with me. John runs it from Maui. I know, right? I know. Yeah, don't feel sorry for John. So I do try to put him to work, like making slides and things, and he made this one for us. Oh, I haven't been able to get this one working. Terry, does this work? Is there a way to turn it on that I don't know? Oh, maybe like that thing right there?
A little button that says on.
It might. It's really small writing. And you would need other glasses for that one. I know, how sad is this? When I hosted this event last year, I don't even think I had to wear glasses. Getting old. Okay, so we're going to talk to you about Kubernetes in the real world because it's gone beyond the point where enterprises are thinking about transforming their architecture to, container-oriented data centers, et cetera. It's happened, and it's not even PCs anymore. See, I knew it didn't work. Right where? Oh, I knew I wasn't crazy. Well, I mean, maybe that's still debatable, but I knew that wasn't working. Okay, so what I was saying is a lot of people are running Kubernetes now, not just in POCs anymore, like actually in production. So can I just real quick see a show of hands of who is running Kubernetes in production? Okay, all right, we got a little more. Oh, hey, hi, Joseph. We got a little more each time. I love this community. It's like all my best friends come to these things. And okay, so this, as you know, has given us some benefits, but also caused some problems. And all the things you expected out of VMs aren't necessarily there natively with the container infrastructures that are set up. So we have a panel of architects and admins and operators and customers and user group managers. And I know that's more than 4 people, so some of us wear multiple hats. But we are going to break it down, tell you some more do's and don'ts, and so that you too can run Kubernetes in the real world. So why don't I kind of start with the first question? How do enterprises transform their architectures with containers without losing all of the reliability and availability that they've come to love with VMs? And I apologize, it's been a really long day.
Is this where we plug your company?
This is where, you can plug any company here. No, keep it community.
Yeah, no, I think moving to Kubernetes is actually a big challenge for a lot of companies. The containerization process isn't just about deploying things into containers, and that's why Kubernetes I think is so powerful, because it's an excellent management platform. But it really does mean that your application development community has to move to cloud native models for their applications. You probably still have to consider that some of the services might need to migrate on a longer time scale. Like, let's just not try to do everything all at once. I think if we can sort of start thinking through some of those processes, we can actually get enterprises into a more cloud native mindset. It's just going to take some time, right?
Right. So one of and I want Michael Richmond to take us in this next direction, because I want him to talk a little bit about what he built at Neo. I teased it a little in the morning session. He has got a rather large database here and in Shanghai, running a lot of cores in production of Kubernetes. And so he's had growing pains, and he's learned a lot. And so if you can explain to some of us, particularly around the area of we saw this with OpenStack, right, when it grew really fast, and then maybe didn't bring the admins and the operators along as fast as we would have liked to, so then a whole bunch of other stuff had to happen. So same with Kubernetes. Are the docs or the tools there for the operators and the admins? And if you can talk about your experience, and then I'm sure Tony will be itching to, to jump in after that.
Sure. So at Neo, we're building electric cars as our primary product. The Kubernetes systems that we're building are to support the development of those vehicles. So we have, in our US data center, which is about 2 miles from this building, we have about 3,000 cores under Kubernetes management. We have another 3,000 cores under DCOS management. In Shanghai, we have about 1,500 cores in Kubernetes and 1,500 in DCOS. We're actually running Kubernetes and DCOS side by side, largely because we were going container native when we started this project 2 years ago when I joined the company, and it wasn't clear what the right container orchestrator looked like at that point in time for the various workloads that we've been needing to run. and needing to build out. So we actually took a model of deploying both leading orchestrators side by side, and the bets that we made on what was best suited for DCOS, in some cases we were correct, in some cases we were wrong, and same for Kubernetes. So we're actually actively shuffling our workload around. But to actually answer your question, one of the things that we've been finding is Kubernetes today is, based on our experience, stable in production. We're running Kubernetes 1.9.4 in our production systems, and the 1.9 series was largely when we were finding Kubernetes was pretty solid. But the path to get to running 1.9 was a long education process and a lot of skills building, because Kubernetes today, in my experience, is somewhat like where OpenStack was in the F and G release cycles, where the technology is there, but it's actually a difficult process to get it deployed and operated.
That's Folsom and Grizzly for those of you keeping score at home. Not everybody's coming through the OpenStack user group.
Sure.
Some people are from some of the other.
I was trying to dovetail between.
Yes, yes. Thank you.
I would like to point out to Michael and Robert that I have a lapel mic.
Oh.
Oh my gosh.
Yes, thank you.
Oh, okay. No, I see the hierarchy now.
Yeah, see how that works?
Okay.
Hi, everybody.
Got
So, Tony Campbell, and some interesting thoughts on this. I agree. There's Kubernetes went through this hype cycle, right, where everybody was trying to get their hands on it, everybody was using it, but not necessarily using it in a way that was production ready. A lot of bumps and bruises we saw in the last presentation. A lot of people were able to shoot themselves in the foot. But the interesting thing is Kubernetes uses a pattern in order to make its components reliable within itself, right? It uses this controller loop, right, that is watching the resources, and it's always trying to reconcile those resources, desired state to the current state, right? So if a pod disappears, this thing is watching, sees that pod disappear, brings up another one, right? That's what Kubernetes does. The interesting thing is we can use that pattern to help build some reliability into Kubernetes itself, where if you have your Kubernetes cluster up and running, and let me back into this. So I'm with Red Hat now, but I came over with the CoreOS acquisition, so I was with CoreOS, and then I was with Rackspace before then. But at CoreOS, we, along with a lot of other installers, started doing this as well. We started to take the control plane of Kubernetes and run as much of that as we could within Kubernetes itself. So, yeah. So the API server, right, was actually running within our Kubernetes cluster. It's called self-hosted. You see it all over the place now, self-hosted Kubernetes. So the API server, for example, was running as a pod in the Kubernetes cluster. So I got my API servers running, and if I lose one of my API servers, it's just a Kubernetes pod. What does Kubernetes do? Brings it back up, right? So that sort of pattern, I think the more we figure out how to make that pattern work in different places, we can help to build more reliability into our Kubernetes clusters.
Okay. I'm going to ask you an interesting question. Well, I don't know. So what I've noticed, so we're going to go a little DevOpsy here, talking about IT admins versus operators versus developers. What's that?
We know where you stand.
Okay. All right. So in my experience, because our user group here, and if I didn't really introduce myself, I'm Lisa, and I've run the SFBay OpenStack user group for the last 5 years, and we're now sort of SFBay Cloud Native OpenInfra, but it's all the same, all one big happy family, same user group. So I know most of you, I think, since I've been around a while. So I've talked to a lot of you, and I know our environment, our community consists of a lot of admins and operators, maybe a third developers, probably that's about the ratio. And so in my experience, I've noticed that the IT admins sort of take a lot of interest in the technical details of launching and maintaining Kubernetes clusters, as opposed to the developers who just sort of think the world is a Kubernetes cluster. You going with me here? I know it's a weird question. And so there's a kind of a control thing about who's developing what, and especially when you introduce, GKE and EKS and AWS. And so where do you think, how much of the development is happening, and is there a handoff, and at what percentage is there a handoff, and how does that happen? And Rob, why don't you take this?
Well, I think, for one thing, I've said for the longest time that developers are not happy with DevOps. They were happy with it because it enabled them, but they're not happy with having to deal with operating system updates. I mean, who the heck wants to do that, right? Operators, on the other hand, are happy with it because they can automate it. They can say, I can build a model against 10,000 machines to automate this process, and it's not as much of a problem for me. So when we split the two, and we say, that's why I say ops dev, I say that there's an operations development process. We should be automating all the things still, and infrastructure as code is still valid. But when we get to the application, why do we want the person who's trying to figure out if they've patched the latest security bugs on their operating system also trying to figure out what next feature they need to build in the application? We have a nice divide now, and Kubernetes gives one model for what that divide looks like. That's why I think there's so much interest in it. So that developers can now focus on how they're consuming Kubernetes resources, and I'm actually a huge fan of the operators thing that the CoreOS folks introduced into the Kubernetes community, because you can actually use that to operate your own application. Right, so now you're thinking about operations from the application perspective rather than the infrastructure perspective. You've moved infrastructure up a level. I think that's why people talk about no-ops, kind of like serverless, two of my least favorite technology names.
You said them both.
Yeah, I know. It's just to throw it all out there, right? Get it all out. Yeah. But I think these are the two key technologies, right? We can break this boundary. Application developers can focus on their application. They still need to think about operating that application. How does it scale? Some of the things in even the previous session, like, don't just assume that cron is going to do the right thing or cron job is going to do the right thing. You have to still be aware of what's going on in that new layer of infrastructure. But you can at least now let go of some of the underlying resources, right? Make them a little bit more flexible. So that's my 10 cents.
10 cents, not just two.
Just to actually add a little to that, a lot of those high-level technologies that you're talking about, serverless, no-ops, et cetera, is largely a move towards saying, there's only one set of skills that we need to operate complex distributed systems, and that's never going to be the case.
Okay.
It's important for everyone, no matter where they live in the stack, to have an understanding of other parts of the stack and maybe be abstracted from the details that are not important to their layer, such as application developers should be able to have an environment such as Kubernetes where they can run their apps and not worry about the infrastructure stuff. But we still need people to worry about the infrastructure stuff. Either those people are hired by AWS because you're running in a hosted environment, or they're your traditional IT people, or they're your operators that you hire to support your applications developers. There's no free lunch. I mean, ultimately, not everything is a completely stateless application. And I'd actually say that nothing is a stateless application.
Michael had one of my absolute most favorite quotes on the planet during Container World when I had him on stage, and he said, the only truly stateless application is Hello World.
Yep.
I have to give him credit
You can
for
actually
it.
apply state to that too, because it is in the code, so.
So I came up as a software developer, and I'm going to have a real vulnerable moment right now. When I first started doing software development, I knew zero about the Linux command line. Nothing. I knew nothing about it. I was hacking out Java day and night, and then somebody told me, hey, put this on that Linux box. I'm like, yeah, how do I change directories? Yeah, so I've come a long way, and now I work for Red Hat. All right, so I've come a long way. But the point is, I think if developers had their way, they would be hacking on applications and not worried about infrastructure at all. And I think us trying to merge those two, I understand what we're doing, so we weren't throwing stuff over the wall. We wanted some sympathy on both sides of the wall. But I think we may have went a little bit too far. And now I think that's kind of pulling back a little bit. One of the things that the cloud providers have done for us is they have spoiled us. Because now I don't have to worry about a NoSQL database. I can go to any cloud provider, click a button, spin one up, connect it to my app. And there's so many cloud services out there that are like that, where I can just consume them and build my application on top of them. I think we've gotten really spoiled with that. The nice thing is we can do the same thing in Kubernetes.
Well,
Well, I mean, here's the thing, right? So that model of, I don't have to worry about the infrastructure leads to major outages, right? I mean, we've seen them even in the cloud providers. It's not that the cloud provider outage wasn't expected. I mean, eventually something's going to break.
Yep.
But then you have somebody who's like, well, US East is the cheapest Amazon zone, so I'm going to put all my servers there. And then US East disappears. And what are they supposed to do, right? Their application doesn't just automatically spin up somewhere else because they didn't automate that, right? So Kubernetes is the same thing, just because it's easy. And you see this a lot. You see a lot of developers that say, oh, well, I'll just deploy Kubernetes, and I've sort of fixed my ops issue. Except that they haven't thought about what it means to actually be running Kubernetes, running it at scale, running it in multiple sites. Resilient applications still have to exist, and that's the piece that
Right.
doesn't go away.
Resilient
we still
and
need to
persistent,
understand,
right?
Yeah.
I mean, with the data, and so I'm supposed to be the moderator, so rather than have my own opinions, I'll quote other people. When I wandered through one of the labs earlier, Dave and Jeff's lab, I heard somebody say that when a Kubernetes container goes down, it's 5 minutes minimum or something to get back up. Is that what you guys said? 5 minutes? Yeah. So what happens to all the data? What happens to that persistent, that stateful application all of a sudden when you lose that container? So you solved this problem, Michael. Can he tell everybody about it? Why did you try? Because you're running stateful applications on Kubernetes, which is a land that people have not boldly gone so much, but they need to. How did you do it?
We're working on that. So we've deployed some technologies at Neo that have simplified a lot of the choices that people would make in deploying Kubernetes, so that we don't have to directly address that challenge today. Kubernetes is great. It schedules, it runs everything. It feels like you're running a process, because fundamentally that's all you're doing is running a whole lot of processes. Pain points come in with container networking and container storage. You can deploy any one of many networking solutions that will either give you a whole lot of overhead and slow down your network terribly, or will give you addressing nightmares that are difficult to debug. At Neo, we chose to go with a hardware-based SDN vendor who worked with us to implement their CNI integration for Kubernetes. That has been going fabulously. That vendor is Big Switch for anybody interested. We also deployed a storage solution for containers from Portworx after working with a number of storage solutions in Kubernetes, and that is providing us network addressable volumes that follow our containers around as they get relaunched in the cluster. All of that works to date, and it has been an evolutionary process to get to the stability that we have, but it's not a solved problem. It is a emerging solution that that the community needs to decide really what types of workloads the community wants to run on Kubernetes. But if you have even if you have a stateful web service, or a stateless web service that is just returning hello world, if you have a 5-minute outage when that restarts, you have a deployment problem.
Goodbye, world.
Yeah.
Yeah, well,
I just got that. I was slow. Sorry.
I just made that up. I told you it's been a long day.
but I think this is also where this operations development automation and application automation sort of come together, right? The application developers cannot be completely blind to what lives underneath Kubernetes environment.
Right.
At the same time, the operations teams can provide resources, can provide tools to make it more resilient, but they still have to explain how the pieces are supposed to fit together. Right? It's not just one size fits all and away we go. It's all done. We still have to sort of tie the pieces together. And I think that's, again, where some of these additional models, like Tony, you had said, right, start using the Kubernetes automation model, the Kubernetes control loop, as a model for managing some of these stateful applications. That's where the controller resource, right, or the operator resource, comes into play. And I think it's a useful tool that can be implemented to support some of those stateful environments when your application expects things to exist, right? Expects your database to always be there. An operator can at least help handle some of the automation tasks, right? So it is something that comes from the ops side of the world, I think, for the most part.
Robert set me up. Can I go?
Yeah, you haven't, go, plug.
What you're also saying is building monolithic applications is easy, building distributed applications is hard. If you want to build an application that scales and is in the Kubernetes mindset or even the VM mindset, you need to be thinking about microservices architectures, replicated architectures. And none of that comes without the cost of understanding what you're doing compared to just slapping code together in one process locally. And ultimately, I think a lot of this is that we're still trying to deliver what Java promised us. Java promised us to write once, run anywhere. And that's actually what Kubernetes is getting as much closer to. It's what AWS got us close to with the VMs. But that's a 30-year-old dream that we're still trying to actually realize.
Yeah, we've talked about this in previous editions of this panel, just about the culture shift that is necessary to move to Kubernetes, the way people have to change the way they think, the way they design applications, the way they think about applications. And you can't just take your monolith, well, you can, but it's not going to be very successful. You can take your monolith and drop it in a container if you want to, but you're not getting all the benefits of that.
That gives you your 5 gig container image that was being talked about in the previous section. So the first piece of functionality that I built out in the microservices, that's the foundation of all of the work we're doing at Neo, was the /status return code or endpoint from my vehicle web service. And that just returned success. But that's the thing that I launched in Docker and then built the rest of the database functionality around, because having the application or a service that you build for Kubernetes be able to actually say, yes, I'm here and I'm healthy, is so fundamental to being able to work in the Kubernetes landscape.
Yeah.
So if you were an operator, I begged Tony to fly all the way here from Austin to talk about this because I personally think it's one of the coolest things, and I talk about it a lot, but since you're the expert.
Okay, I have a lightning talk on it, but I got more time here than the
You
lightning.
will be here for the lightning talk. No, you do not. You have less.
Kidding,
Go.
okay. So I don't know if you guys heard of the operator framework, but just real quick to throw this out to you, we've mentioned it a couple of times. So the idea in Kubernetes is we take that control loop and we use it for our own software, right? So if I have an application that has certain operational requirements, here's how I back this thing up. Here's how I restore it. Here's how I upgrade it. Right now that knowledge is in the mind of an operator, a person, right? What we're doing with the operator framework is we're allowing you to take that knowledge, put it into code. You're going to put that into Kubernetes code, and you're going to run that into your system with a control loop, right? So instead of me as a sysadmin watching this to see what happens when I need to back this up, and I'm physically doing it, the controller is watching that resource, and it says, oh, I see I need to back that thing up. And it fires it off and does the backup.
It's checking Michael's status endpoint.
There it is. It's checking the endpoint that Michael created. Yeah.
So let me add to that, though.
Yeah.
I question the need for backup. If this is truly immutable infrastructure that has been deployed and you have a deployment file somewhere, yes, there may be state behind it and state needs to be backed up, but the application itself, the stuff that's deployed, should never be backed up from Kubernetes. You should be backing up the thing that you fed to Kubernetes in order to deploy stuff. If people are going to Kubernetes and messing with deployments directly, that's not repeatable when you need to reboot your system.
But it's that operation, it's that model of deployment,
Absolutely.
whatever that is, right? If it's
Right.
doing backups and recovering from them, or
Installs.
throwing that away, getting from another source
Right.
and restarting, that's the operator framework model.
Right.
That's what he was.
Absolutely,
Yeah.
Right.
absolutely.
Right. So whatever that, if you're not doing backups on your systems, more power to you. If you have it, you don't need them. I mean, not that way, right? If you don't need them, awesome that you've gotten to that path. But the idea is like if you need to do an update. You know, for example, if you have software out there running and you need to do an update, you can codify that into an operator that can automatically allow you to do that. That's something that we're really pushing now, that we're trying to push through the Kubernetes community. You can see us on Kubernetes Slack, Kubernetes-operators, if you want to talk more
I
about
thought
it.
it was GitHub/operators.
That's that too. If you want to see the actual framework, thank you,
Yeah.
Lisa. If you want to see the actual framework, it's on github.com/operator-framework. We have an SDK, we have an operator lifecycle manager. It's all open source. Come join us as we push the operator revolution.
Okay, so I saved the hardest question for last. And actually, interesting what you just said, Michael, may change the answer to this. But whose responsibility is the security? Is it the platform? Is it the app? How do we secure this stuff? Yes,
Yeah.
Everyone.
everyone, but a little more specific. What are you doing in your data center?
Specifically everyone. We have a security team that's part of our IT operations, which is separate from my team, that's looking at overall company security, and they have strong input into what we're doing. We have parts of our system that we are designing / implementing to address container level or microservice level security. And this is a great opportunity. We're also hiring for operators and security experts to join my team and help us build out this analytics.
And they're right across the street. You saw them if you drove into that side of the parking lot. They are right across the street.
Nice.
And as you can see, if that's the internet Michael, he looks the least like probably. That's what the real
Next
Michael looks
3
like.
startups to go.
So find him. You're going to be around mingling. And okay, and who else from Neo is here, by the way? Awesome, right on. We love Neo. Okay, so find the Neo people and let them tell their story. It's a really, really cool story. Okay, last words. We got 2 minutes.
Use Kubernetes.
Yeah, don't roll your own. I mean, seriously.
I think don't be scared about any of this technology, but be aware that it's not just the one solution fixes all ills, right? It brings its own problems, and as long as you work through them, just like any of the technologies there, I think it is maybe easier to operate in the long run than some of the things we've seen come before it. But it certainly doesn't solve all problems, and take it easy. It doesn't have to be instant.
Kubernetes native or distro? I'm going to ask you because these two did it differently.
Native, man. I mean, always.
Yeah, that's
open
what he
source
did.
all the way.
So we went native, and I'd do it again. I'd also say that I've been fairly strong in my comments about Kubernetes being stable. I had one of my data scientists launch an analytics job last week that consumed 1,000 cores for an hour of processing, and it ran to completion and has consistently run to completion every time he submitted that job. This is one of the data points that makes me confident about Kubernetes. I also need to spend some time with my team optimizing that processing, because that was an hour of processing to process 30 minutes of data. But that's a problem for tomorrow.
Yeah, absolutely.
Last word, Tony.
Kubernetes operators, the key to automated operations. Join us.
Oh my gosh. Oh my gosh. And I'm Lisa-Marie Namphy, and it has been a pleasure to be managing and orchestrating and architecting this user group for 5 years. John Starmer.